Hello everybody and welcome back to my channel. Lots of you requested math, so today we're going to work on a few math problems. My plan was to also prepare a quiz where after watching this video, you can work and really solidify the understandings of these type of problems. The thing is that I got into some tech issues with the quiz, so you're still going to receive the quiz but in a PDF format. The reason I want you to work on this quiz is because when it comes to FE exam, it's not only about knowing the examples, it's also about working and solving them very fast. If you're interested in some practice problems to really make you understand and be confident on the exam, click the link below and I will send the quiz to your email inbox. If you're following me for a while, you also know that I have another guide called How to Evaluate Your Education in the United States of America. And this guide is for all of you with an engineering degree from outside of the United States. If you are interested in doing a credential evaluation, I have put together a PDF guide with step-by-step instructions on how to do that. Click the link below and I will send it to your email inbox. Okay, so that being said, I believe we are ready to start. Grab a few pieces of paper, a pen. Also, you can grab your coffee, as I have it here, your tea, whatever works for you, and let's begin. Integral calculus. When learning about integrals, you have come across two types of integrals, a definite integral and an indefinite integral. A definite integral is an integral that contains the upper and lower limits. A definite integral is represented as shown here, integral from a to b of fx dx, and this equals to capital Fx from a to b, which equals to fb minus fa. An indefinite integral is defined without the upper and lower limit and is represented as integral of fx dx equals to capital Fx plus c, where c is a constant and the function of x is called the integrand. Hopefully in our future videos, we can talk more about this c and understand what it is, where it comes from, and why do we need it. In today's video, we will talk about standard integral, integration by parts, integration by substitution, and integration by separate variable. Let's start with standard integral. A standard integral you are all familiar with is a list of all the common integrals which are available in the FE handbook and also available to you during the exam. Now let's work on a few examples. So for standard integrals, I have a few examples, but looking at them, it seems that they're pretty straightforward. So the easiest one, I will leave it for you to solve. So this is integral from 1 to 3 of 2x dx, and this is case number 5. Just go ahead and solve it and let me know in the comments below the correct answer. Same here, problem number 2. What is the value of the following definite integral? Integral from 0 to 2 of dx over 5x plus 3. If you look in the FE handbook, and I hope you have the FE handbook with indefinite integrals formulas in front of you, this is case number 7. Just go ahead and apply the formula. This example is also pretty straightforward, so I will not solve it. I will have you do it. And let me know in the comments which is the correct answer. Example number 3, it shows here 1 is 3, never mind, it's fine. What is the value of the following definite integral? Integral from 0 to 1 of 7 power x dx. Again, going through all the formulas in the FE handbook, this is case number 9. Go ahead and solve it and let me know what is the correct answer. Moving forward, we have example number 4, and this is the one I will solve. And let's look in the FE handbook. You will notice the 27a, 27b, 27c looks exactly like what we have here. In order to identify which case are we have to, for 27a, we have to calculate 4ac minus b squared, and this has to be greater than 0. For 27b, b squared minus 4ac has to be greater than 0. And for 27c, b squared minus 4ac has to be equal to 0. So let's start with case 27a and calculate 4ac minus b squared. And if it is greater than 0, then this is our case, our formula. So 4ac minus b squared equals to 4 multiplied by a, which is 3, multiplied by c, which is 3, minus b squared. B in our case is minus 5, so we put it in the parentheses, and it is squared. This equals to 36 minus 25, and it is 11. So it is greater than 0. This means that this is our case, our formula, 27a. Let's go ahead and write the formula down. So our integral equals to 2 over square root of 4ac minus b squared multiplied by arctangent of 2ax plus b over square root of 4ac minus b squared. And this, let's substitute now, and this will be equal to 2 over square root of 11 arctangent of 6x minus 5 over square root of 11. And this is from a 0 to 4. And now, moving forward, we have to apply the formula of a definite integral, which equals to fb minus fa. In our case, b is 4 and a is 0. So let's go ahead and do that. Integral equals to, and I am moving 2 over square root of 11 in front of the parentheses because it is a constant. So we'll have 2 over square root of 11 multiplied by arctangent of 6 times 4 minus 5 over square root of 11 minus, and fa is arctangent of 6 times 0 minus 5 over square root of 11. Let's do the math here, and we'll have 2 over square root of 11 of arctangent of 19 over square root of 11 minus arctangent of minus 5 over square root of 11. And a note here, when you calculate these types of problems, your calculator has to be in radian mode. Otherwise, you will not get the right answer. So using your calculator in radian mode, you should get 1.437. And looking at the answers, the correct answer is B. Now let's talk about integration by parts. You use integration by parts when you have an integral of a product of two functions. In FE Handbook, this is case number 6. So in order to solve this, you have to know which function should be designated as U and which should be designated as V. To help with that, use these initials, remember them, ILATE, ILATE, which stand for I inverse as inverse trigonometric, such as sine to minus 1, cosine to minus 1, logarithmic, algebraic, trigonometric, exponential. You must compare the two functions, and the one that ranks higher on this list is going to be classified as U. The correct choice of U and dv is critical. The formula will not work if these are reversed. Now let's go ahead and work on an example. What is the following integral? Integral of x squared multiplied by e power 5x dx. So this is case 6, and the formula from the FE handbook is integral of u dv equals to uv minus integral of v du. So let's go back to our ILATE initials and identify which one is u and which one is dv. So we have x squared, and this is an algebraic function, and we have e power 5x. This is an exponential function. So looking back at this list here, notice how algebraic ranks higher than exponential, which means that u dx is going to be equal to x squared. Let's go ahead and write that down. So now the rest of the integral is our dv. Let's write this down. So dv equals to e power 5x dx. In order to calculate v, we have to integrate dv. Let's go ahead and do that. We'll have v equals to integral of dv, and this is just a pretty straight formula, integral of e power 5x dx. Looking in the FE handbook, This is case number 22. And let's just go ahead and apply that. It will be equal to 1 over 5 multiplied by e power 5x. So it results that v equals to 1 over 5 multiplied by e power 5x. So now that we know that, let's go and apply the formula. Integral of u dv equals to uv minus integral of v du. So let's substitute. We have u as x squared and v as 1 over 5 multiplied by e 5x. Let's write this down. X squared multiplied by 1 over 5 times e power 5x minus integral of v. Again, we're going to substitute v here, which is 1 over 5 multiplied by e power 5x multiplied by du. Attention here, du, we haven't calculated it, but in this case it's really simple. And let's go back to u. Du is derivative of u, and in our case, u is x squared. If you don't know how much is derivative of x squared, let's go to the FE handbook and look up formula. Find the list of derivative formulas, and x squared is formula number 8, where u power n equals to n times u power n minus 1. So in our case, du is going to be equals to 2 multiplied by x power 2 minus 1, and this equals to 2x. So moving forward, let's calculate this. We get x squared over 5 multiplied by e power 5x minus, and here inside the integral, we're going to bring the constant in front of the integral, and we have 2 over 5 multiplied by integral of, we're left with x times e power 5x. So again, we have an integral to calculate, and this integral has a product of two functions, and we can use the same method identifying which one is u and which one is dv. But if you look carefully at this formula, you have it in the FE handbook. And this is case 23. If you go and look quickly at case 23, you will have integral of x multiplied by e power ax dx. So we have a formula. We don't have to do integration by parts here. We can just go ahead and apply the formula. So let's calculate that integral. Integral of x multiplied by e power 5x dx equals to e power ax over a squared multiplied by ax minus 1. Let's substitute, and we get e power 5x over 5 squared multiplied by 5x minus 1. So now that we have calculated that, let's go back to our final equation of our initial formula and replace this integral with this result. So the integral equals to x squared over 5 multiplied by a power 5x minus 2 over 5, and now I'm going to add the integral formula which we just calculated, multiply by e power 5x over 5 squared multiplied by 5x minus 1. I hope you're following me. If not, you're welcome to just stop and go as slow or as fast as you need. So now we'll have to multiply and open the parentheses. I'll write the first term the way it is, x squared over 5 multiplied by a power 5x minus, and now I will multiply this term with 5x and this term with 1, but I will keep the things the way they are. I will not do the multiplication. So we have minus 2 over 5 multiplied by e power 5x over 5 squared times 5x. And moving forward, we have plus because we have minus and minus. When we multiply, minus and minus becomes plus. So we have plus 2 over 5 multiplied by e power 5x over 5 squared. Okay, so this integral, let's see, we're going to bring e power 5x in front of the parentheses because it's the common term in all of these three. So e power 5x comes in front, open the parentheses, and let's see what we are left with. We are left here with x squared over 5 minus 2x over 25. And this is because 5 and 5, they reduce each other. So we are left with 25 plus 2 over 125. And looking at the answers, you'll notice the correct answer is C. Integration by substitution. What is the definite integral? Integral from 0 to pi of 1 plus cosine squared x multiplied by sine x dx. We often use integration by substitution to simplify the process of integration. So the way it works, you substitute one term in your integral, make it equals to u, and automatically you do derivative of that u. And this should bring your integral to a form that it's easy to calculate. Let's go ahead and do that. In our case, we will substitute cosine x equal to u. And then we will do derivative of u, which is equal to minus sine x dx. And now let's go back to our integral and substitute cosine x with u and du with minus sine x dx. So we'll have our integral, we have the minus in front from the du, which is minus sine x dx. And we're going to take the minus in front of the integral. We have 1 plus u squared multiplied by du. Now this integral has a form that is easy to calculate. Let's go ahead and do that. This will equal to minus in front, don't forget the minus, integral of du plus integral of u squared. This equals to integral of du equals to u plus integral of u squared equals to u power 3 over 3. And of course, we have the minus in front. So now we can go back and substitute u with the initial cosine x. Let's go ahead and do that. We'll have minus in front, cosine x plus 1 over 3 cosine power 3 dx. And this, the upper and lower limit is from 0 to pi. So now we have to do fb minus fa. In our case, we have f pi minus f0. Let's go ahead and do that. The integral will be equal to, don't forget the minus. It's very important to pay attention to the signs because otherwise you will get a different answer and get it all wrong. So we're going to keep the minus in front, and f pi equals to cosine pi plus 1 over 3 cosine power 3 of pi minus from the initial formula, and then you have the minus from our equation, and now we got cosine 0 plus 1 over 3 multiplied with cosine power 3 of 0. Moving forward, cosine pi is minus 1, so we'll have minus in front, minus 1 plus 1 over 3 multiplied by cosine of pi power 3 is still minus 1, so we'll write that down. And now moving forward, we've got minus and then minus. So minus multiplied with minus, we know it's plus. So I've got plus cosine 0 is 1 plus 1 over 3 cosine of 0 power 3 is still 1. So again, let's do the calculations. We have our integral equals to minus and minus, as we've talked, is plus. So we'll have 1 plus, again, minus plus minus is 1. 1 over 3 plus 1 plus 1 over 3. To simplify this, we get 3 plus 1 plus 3 plus 1 over 3. And this equals to 8 over 3. So the correct answer is A. Integration by separable variables. When you have an equation of this form, dy over dx equals to f dx over gy, the equation can also be written as fx dx equals to gy dy. And in order to solve this equation, we have to integrate both sides. Let's work on an example. Solve the following differential equation. dy over dx equals to sine 5x over y power 3. So let's rewrite this equation as y power 3 dx equals to sine 5x dx. And now let's integrate both sides. So we'll have integral of y power 3 dy equals to integral of sine 5x dx. These are simple integrals, straightforward formulas that we can just look up in the FE handbook and solve this. So integral of y power 3 dy equals to y power 4 over 4, and this equals to integral of sine 5x. Pay attention here, you don't have this formula in the FE handbook. You only have sine x or cosine x, integral of sine x of integral of cosine x. I think this formula, you just have to remember it. When you have sine ax or cosine ax, you have the same formula, you just have to bring in front 1 over a, and then you keep the cosine 5x. So you keep everything the same, you have to bring in front 1 over a. So in this case, we have sine 5x, and looking in the FE handbook, sine x equals to minus cosine x. So in my case, if I have sine 5x, I will have 1 over 5, of course with minus in front, cosine of 5x. So please make a note, you have to remember this formula. And then, of course, plus c, all the indefinite integrals have this constant plus c. Now let's simplify this and multiply by 20, and we'll get 5y power 4. Moving this negative term on the other side of the equal sign makes it positive, and we'll have 4 cosine 5x equals to constant c. Looking at the answers, the correct one is D, 5y power 4 plus 4 cosine 5x equals c. I hope this video helped clarify a few things about integrals. If you found this video helpful, please subscribe and give it a like, because this helps my video reach more people just like you. If you have any questions, do not hesitate to leave it in the comment section below. Don't forget to check underneath this video for all the links that I'm mentioning in the video. Keep up the good work on practicing the FE problems, and I will see you next week.